Hey everyone, and welcome to lesson 2.2, solving two-step equations. I want you to go ahead and set up your Falcon notes in the correct format, and then we're going to start with our essential question, how can we use number properties to solve linear equations and justify a solution method? So the first thing I want to do is define our three number properties that we have, which are our commutative, associative, and distributive properties. Our commutative property just basically tells us that if we are adding two numbers together, the order does not matter. Basically, if I add A and B together, that is going to be the same thing as if I added B and A together. For instance, 4 plus 2 gives me the same thing as 2 plus 4. This also applies to multiplication. A times B is the same thing as B times A. And using the same example, 4 times 2 would give me the same thing as 2 times 4. Our second property is the associative property, and this one tells me that if we are grouping numbers with addition or multiplication, the order of that grouping does not matter. So for instance, in this first example, I have B plus C grouped and then I'm adding A. But if I were to change the grouping to A and B and then add C, I would get the exact same answer. And this also applies to multiplication. If I were to group B and C and multiply those and then multiply A, it would be the same thing as if I grouped A and B and then multiplied by C. Our last property is our distributive property, and this happens when we have a number directly outside a parenthesis that has maybe two or more things inside the parenthesis. So this number outside the parenthesis has nothing in between the parenthesis and the number. For instance, there's no addition sign, there's no subtraction sign, there's absolutely nothing. This tells me that I need to multiply. And the way that we do this is we take that number on the outside and we multiply it to the first thing in the parenthesis first. So I do A times B. And then I take the number on the outside and I multiply it to the second thing in the parenthesis, A times C, which gives me a positive AC, and we put that plus sign right in there. So we are going to use these three properties to help us solve two-step equations. And there's a few steps that we can kind of use as a guide when we're trying to solve these equations. The first is to get rid of any parentheses that you may see in your example. Then you want to move all the x's to the same side. This is only if you have more than one x in your equation. Then you want to combine like terms. If you have anything that has just a plain old number, we want to combine those, or if you have any terms that have an x, you want to combine those. And then to get x alone, we have to add or subtract numbers away from it, or multiply and divide numbers away from it, and then we check our work. So we're going to start with some examples. We have 5 examples to go over today. The first example that we have is 3x plus 5 equals negative 15. So I'm going to identify how many x's I have. I have just one x, which is good for us because that means we don't have to combine any x's together. So I'm going to split up my equation into a left side and a right side by drawing that line all the way down from my equal sign. So my x is on the left-hand side right now, so that means I need to move any numbers that are attached to that x to the right side. And remember, when we move numbers, we have to use opposite operations. When we are solving, the first thing that we want to do is we want to add or subtract any numbers away from x that we may have. So right now, the two numbers that are attached are a 3 and a plus 5. The 3 is being multiplied because there's nothing in between the 3 and the x, so I know that's multiplication, and the 5 is being added. So this 5 is what I want to move first because we want to, again, add or subtract numbers away first. So in order to get rid of that plus 5, I need to subtract 5 on both sides. In doing so, I haven't touched my 3x, so I just bring that down to the next line. My 5's cancel each other out, and then I have negative 16 minus 5. We have two negatives here, so I take the sign and I add the numbers. 16 plus 5 gives me 21. Now, I just have this 3 that's attached through multiplication left to get rid of. In order to get rid of that 3, I need to do the opposite of multiplication, which is division. So I'm dividing both sides by 3. My 3's cancel out, leaving me with just an x. And then negative 21 divided by 3 leaves me with negative 7 because a negative divided by a positive is a negative. So I found my solution for x. Now all I want to do is check my work, and I check my work by plugging back into the original equation. So my original equation is 3x plus 5, and that equals negative 16. So the solution that I got was x equals -7. So wherever I see an x in my equation, I'm going to replace that with -7. So I have 3, and now here's my x. So I'm going to replace that with -7 in parentheses. Then I have +5 equals -16. Now I have to follow my order of operations. 3 times -7 gives me -21. I bring down my +5, and I bring down my -16. -21 and 5 are different signs, so we subtract the number and take the sign of the larger number. So 21 was larger, so I'm going to take the negative sign there, and then I have -16 equals -16, and this checks out. So let's move on to number 2. This problem is very similar to number 1 that we just did. I want to get x by itself, so I'm going to split this up into 2 sides, my left side and my right side. So right now my x is on the left side, so that means I need to move all numbers to the right-hand side, starting with anything that is being added or subtracted. So the only number right now that's being added or subtracted is this -7. So to get rid of -7, I have to add 7 on both sides. So when I do that, I am left with 9x. It just gets dropped down to the next line. My 7's cancel each other out. And then on the other side, I have -7 and 7 again. These ones will not cancel out this time. These one will give us a 0. On this side, we were left with a 0 as well, but we didn't necessarily have to write that because we had the 9x still left over. But on the right side, if we cancel out the -7's, we have to make sure that we put that 0 there, or else we'll be left with nothing on the right side and we can't continue to solve that equation. Now the last step here that we have to do is get rid of that 9, which is being multiplied out in front. So to get rid of multiplication, we divide. So my 9's cancel out, leaving me with just an x. And then 0 divided by 9 is just 0. 0 divided by anything is 0. We can divide by 0 by a number, that is okay, but we cannot divide anything by 0, then you get knocked out. So let's go ahead and check our work here by plugging 0 in for x. So starting back at our original equation, 9x minus 7 equals -7. I'm going to plug in 0 for x. So in place of x, I put 0 in parentheses. Then I subtract 7. 9 times 0 is 0. I bring down my -7. 0 minus 7 is just -7. So I end up with -7 equals -7, and this checks. All right, let's step it up a notch and look at problem number 3. We have 2 and then parentheses n plus 5 equals -2. So I see that I have parentheses here. The first thing that I want to do is get rid of those parentheses, and I do that by using the distributive property.